Routed bridging, a use case module. By the end of this module, you should be able to describe how to configure centrally routed bridging. The diagram shows the topology for this configuration section. In this sample configuration section, there are 4 devices, 2 spine devices, S1 and S2, and 2 leaf devices, L1 and L2. Each leaf has multiple hosts from the blue and green VLANs. The VXLAN routing occurs on the spine devices, which means you are using the centrally routed bridging or CRB fabric design.
The purpose of the underlay network is to provide connectivity for the overlay network. External BGP, which is abbreviated as EBGP, is used to provide that connectivity. The example shows the EBGP configurations for the spines, S1 and S2, and the leaf devices, L1 and L2. There is an export policy applied to the BGP groups that matches on the loopback interfaces and exports them into the network. These loopback addresses are used for the BGP peering that is required for the overlay network. You can use another routing protocol such as OSPF or ISIS for the underlay network if required.
Both spines must have BGP overlay sessions configured. You must configure the overlay BGP groups to signal the Ethernet VPN or EVPN protocol family and any parameters that are necessary for the BGP sessions. The example shows an eBGP configuration with family EVPN signaling, which creates a BGP group database with only EVPN route information. With a full mesh overlay, each device has multiple paths to other devices. You must implement the multipath BGP option, since the spine devices will be EVPN neighbors with the leaf devices and will handle all the routing. You must configure switch options, VLANs, the EVPN protocol, and routing instances on the spine devices. Though not shown, all standard BGP protections such as BFD, log up down, VPN apply export, and so on should be configured in a live environment. You must configure the spines with switch options. The VXLAN tunnels form from leaf to leaf for layer 2 and leaf to spine for layer 3. So, set the virtual tunnel endpoint or VTEP source interfaces on the devices. In this example, the VTEP source interfaces are the loopback interfaces in the default routing instance. Then, configure route distinguishers or RD and the route targets. This configuration is the same as a basic EVPN-VXLAN setup where edge routing and bridging or ERB or CRB are not configured. The VLAN configurations for the spine devices have the normal VLAN to VXLAN mappings and the associated integrated routing and bridging or IRB interfaces for the layer 3 interface of the VLAN. In the example, the blue VLAN has a VLAN ID of 10. It is mapped to the VNI of 5010 and uses IRB.10 as the layer 3 interface. The green VLAN has a VLAN ID of 20. It is mapped to the VNI of 5020 and uses IRB.20 as the layer 3 interface. The IRB interfaces on the spines act as the VXLAN layer 3 gateway for each VLAN. This functionality provides the ability for hosts in different VLANs to communicate with each other as they send inter-VLAN traffic to the virtual gateway address of the IRB interface. The example only shows the configuration for spine S1. However, it is very similar on spine S2. Interface IRB.10 is used for the blue VLAN, and interface IRB.20 is used for the green VLAN. Both of the IRB interfaces use a main IP address and a virtual gateway address that is within their respective VLAN subnets. The main IP addresses are unique for each spine, but all the spines share the same virtual gateway addresses for redundancy. If you are familiar with the Virtual Redundancy Router Redundancy Protocol, or VRRP, the functionality of the virtual gateway address is similar. The output shows the IRB configuration for spine S2. The EVPN protocol configuration on the spine devices is the basic configuration that is used for an EVPN-VXLAN network when deploying an overlay. The EVPN protocol uses VXLAN encapsulation, and the extended VNI list is set to all. When deploying an IBGP overlay where every node has the same AS number, The VNI options configuration shown for the EVPN protocol is not required. However, it can still be used to limit table population. With CRB, the VXLAN Layer 3 gateways are found on the spines, and so the virtual routing and forwarding or VRF routing instances are configured on the spines. Within the routing instances, you must specify the instance type, VRF, the Layer 3 gateway interfaces, the IRBs, the route distinguishers, and the route targets. The route distinguishers must be unique, but the route targets must match on each device. This configuration enables routing within a customer EVPN-VXLAN fabric. If routing is required to external devices, routing policies must be configured and applied. The Leaf BGP configuration mirrors the BGP overlay configuration of the spine devices. The Leaf devices only peer with the spine devices using EVPN signaling. Leaf devices do not form BGP neighbor peering with each other, as the spine devices are configured as route reflectors to handle route propagation to all the Leaf devices. This configuration helps with scaling, as each new Leaf that is added to the fabric doesn't require you to add to the BGP configuration of all the existing Leaf devices in the fabric. With each spine device providing paths to the Leaf devices, you must implement the multipath BGP option. You must configure the Leaf devices with the switch options. The VXLAN tunnels form from Leaf to Leaf and from Leaf to spine, so you must set the VTEP source interfaces on the Leaf devices. In this example, the VTEP source interfaces are the loopback interfaces in the default routing instance. Then, configure route distinguishers and the route targets. This configuration is the same as a basic EVPN-VXLAN setup. The VLAN configurations for the Leaf devices have the normal VLAN to VXLAN mappings. Since the routing is done on the spine, there is no L3 interface mapping on the Leaf devices. The example shows that the blue VLAN has a VLAN ID of 10 and it is mapped to the VNI of 5010. The green VLAN has a VLAN ID of 20 and it is mapped to the VNI of 5020. The EVPN protocol configuration on the Leaf devices is the basic configuration that is used for an EVPN-VXLAN network. The EVPN uses VXLAN encapsulation and the extended VNI list is set to all. When deploying an IBGP overlay where every node has the same AS number, the VNI options configuration shown for the EVPN protocol is not required. However, it can still be used to limit table population. Since each server is dual-homed, EVPN multi-homed interfaces are configured on the Leaf devices. The example shows the configuration for the blue VLAN connectivity to the servers on L1 and L2. Notice the configuration for Ethernet Segment Identifier or ESI on each node. The ESI auto-derive LACP command automatically creates ESIs from the Link Aggregation Control Protocol or LACP system ID configuration. The auto-derive option is explained in the EVPN overview module. The code shows the configuration for the green VLAN connectivity to the servers on L1 and L2. Welcome to the Configuring Centrally Routed Bridging Lab module.